Hi everyone, are you ready for our new lesson? Let me show you this figure and take a look closely in relation to our topic for today. FYI, did you know that the properties of hyperbolas have been used in the design of certain telescopes and navigation systems? Wow! A very nice applications in real-life example of hyperbola. That is now our lesson for today. It's all about hyperbola. Now, let us have now the different learning competencies. The first one is we're going to define a hyperbola. We are going to write a standard form and then the general form of the equation of your hyperbola. And of course, we're going to graph a hyperbola in a rectangular coordinate system. Okay, let's proceed. Right. Take a look on this figure again. Okay, if the plane intersects both halves of your double cone but does not pass through the apex of your cones, okay, that is now your hyperbola. Okay, now it is a type of smooth curve lying in a plane defined by its geometric properties or by equations for which it is the solution set. It has two pieces called connected components or the branches. Take a look here. And these branches are said to be the mirror images for each other and resemble two infinite bows. That's defined formally a hyperbola. It is said to be a set of all points whose distances from the two foci differ by a certain constant. If you take a look on this figure, okay, now if we subtract your shorter segments, for example, this short green, this short blue, and this short orange, from your longer, okay, longer segments with these longer segments. Okay, again, if you subtract your small or short segments from the long segments for each ordered pair, the remaining value is constant or the same. That is why, from our definition, its distances from the two foci differ by a certain constant. Okay? Now, let us have the different properties of our hyperbola. Hyperbola is said to be centered on a point called your center of hyperbola. Okay? And this point on each branch closest to the center is this called now your vertex. So from the center, the very close point is vertex. The vertices are some fixed distance labeled as A, and it is usually called as the real semi-axis from the center. Okay, the line going from one vertex to the center to the other vertex is called now your transverse axis. Now, the foci of your hyperbola are inside each branch, labeled as your F1 and F sub 2. Okay, its focus is located some fixed distance called your C. So your distance from center to your focus, okay, and you see now is called your linear eccentricity of the hyperbola. In the transverse axis, remember this one guys, okay, they're located the center, they're located the vertex, they're located your focus or your foci, and they are said to be lined up side by side parallel to the axis of symmetry, that is on the transverse axis. Okay, on the other hand, okay, your B or the distance from the center to your ends of minor axis is called now your conjugate axis. Okay, and of course, the line segments through your F sub 1 and line segment from F sub 2 is said to be perpendicular to the major axis are called now your latera recta, and each has a line of 2b squared over a. And to make it symmetric, what do? We simply divide it into two to locate the ends of our latera recta or your ELR from the focus, okay, from the focus to your ELR. Okay. And of course, as x and y get larger, the branches of your hyperbola approach a pair of intersecting lines called now your asymptotes. And these asymptotes pass through the center of our hyperbola. To sketch the asymptote, we need to draw a dotted rectangle from that 4 points from our vertices. So here is our vertex. We draw a dotted line there. Okay. And then from our co-vertices or your EMA, you draw again dotted lines and it would form a rectangle. From there, you draw asymptotes as the dotted lines that pass through diagonally through the rectangle. Okay, so that is how we form an asymptote. Okay, let's proceed with our standard form. Again, there are two types, and the first one is centered at origin. As you take a look on our figure and our standard form of equation, we have here x squared over a squared minus y squared over b squared equals 1. Okay? Our a squared is referring to our major axis or our transverse axis. So this means our graph shows here that is said to be horizontal along your major axis or your x-axis. On the other hand, okay, on this figure, together with the standard form, y squared over a squared minus x squared over b squared equals 1, you notice that our major axis is said to be what? On its vertical transverse axis or along your y-axis. So take note again, our major axis or transverse axis is always positive. Okay? And on the other hand, your negative is said to be your minor axis or your conjugate axis. That is with respect to center at origin. Now, let's proceed on the second type of your standard form, and that is centered at HK. The same concept on what we have for our centered at origin. Okay, the only difference is that the center is at HK. From here, our standard form, quantity x minus h squared over a squared minus y minus k quantity squared over b squared equals 1 is said to be again what? A horizontal transverse axis because your major axis is said to be parallel to your x-axis. That's why horizontal. On the other hand, on this figure, with respect to your equation, okay, our major axis is said to be a vertical transverse axis parallel to our y-axis. Okay, again, our standard forms are always equated to 1 and your major axis is always positive with respect to a squared. Let's proceed with our general form. Okay, for our general form, take note of this that both your variables x and y are said to be on the second degree. And of course, the numerical coefficients have the same or have different signs. Okay, again, they have different signs and of course different numerical coefficients. We have your x squared minus by squared plus cx plus dy plus e equals 0. From our example here, they have different numerical coefficients and different signs. The other one is positive and the other one is negative. Okay, but both your x and y are said to be on the second degree. And of course, take note, when we see general form, it is always equated to 0. As we compare with the standard form is equated to 1. On the other hand, general form is equated to 0. Now, how about our steps in converting standard form to general form? For this example, we have x minus 2 quantity squared over 16 minus y minus 3 quantity squared over 9 equals 1. Okay, so this is standard form. Rewrite that or convert that to general form. We have here denominator 16 and 9. All we need to do is simply cross multiply. So meaning this 9 is to be written on this x, 16 is to be written on your y. And of course, this is to be cross multiplied or multiplied on the other side also. That's why we have here, okay, after we cross multiply, there you have it. Okay, and then after we cross multiply, the next step is we are going to expand the binomial. Your x minus 2 quantity squared, when we expand that one, there you have it. Then expand the second binomial, y minus 3 quantity squared, there you have it also. And of course, simplify your constant on the other side, which is 16 times 9, we have here 144. Afterwards, we are now ready to distribute your external factor, which is 9 and 16. If we distribute 9, there you have it. We distribute negative 16 to these three terms, there you have it also. And of course, your constant is to be written now on this side. Okay, so that's why when you transpose, it will change sign. And of course, we equate to 0 because we all know general form is always equated to 0. There you have. Then we are now ready to arrange our terms in our general form. And that is, of course, starting from our x squared, which is 9x squared, followed by your negative 16y squared minus 36x plus 96y. And then, of course, simplify our constants. We have here 36, negative 144, negative 144. So therefore, we have negative 252. And do not forget to equate it to 0 because that's an identity of a general form. So again, this is our steps. When we convert the standard form to general form, we cross multiply the denominators, okay? And then expand your binomials. After expanding your binomials, distribute the factor. Then, of course, arrange the terms in combining like terms also, and specifically the constants. And, of course, do not forget to equate to 0. Okay, we are now ready to convert this time from general form to standard form. From this example, 9x squared minus 4y squared minus 54x minus 16y plus 29 equals 0. So all we need to do here is to group those terms with the same variables. So with respect to x, 9x squared and 54x also, group also negative 4y squared and negative 16y. And of course, our constant is to be written on the other side. There you have. We have formed two groups. After grouping those terms with the same variable, we are now ready to extract the numerical coefficients of your second degree. So meaning, on this first group, extract 9. Then on this second group, we are to extract negative 4. So there you have it. After extracting the first group, after extracting the negative 4 on the second group, there you have it. Okay, and this is now what? The next step is we're going to apply completing the square method. Okay, so remember, when we apply completing the square, our middle term, which is negative 6, divided by 2, then square it, it's equals to 9. This 9 is to be written in the first blank. And of course, do not forget, to make it balance, you're going to write here also, which is the product of the external factor and your constant. So 9 times 9 is equals to 81. There you have it. The same true here. To make or to write here in your blank, the value is, we applied, of course, our completing the square method, 4 over 2, then square it. It's 4. There you have it. And then, of course, you're going to write. Afterwards, to make it balance on the other side, negative 4 times 4, it's negative 16. There you have it. Now, we have already a perfect square trinomial. The next thing to consider here is we need to extract it or factor it out. So we have here quantity x minus 3 squared. Factor this also, which is y plus 2 quantity squared. And of course, simplify our constants. Negative 29 plus 81 plus negative 16. As we simplify it, we have 36. So there you have it. After applying, completing the square, then of course factoring out, there you have. Remember, when we say standard form, it is always equated to 1. So therefore, to eliminate this 36, we are going to divide both sides by 36. And then afterwards, we are now ready to simplify our factors. 9 over 36, it is said to be 1/4, or simply x minus 3 quantity squared over 4. The same true here. What is negative 4 over 36? Get the lowest term, and that is negative 1 over 9, or simply y plus 2 quantity squared over 9. And of course, 36 over 36 is simply equals to 1. So there you have it, our standard form. From our steps, again, group the terms. When you see terms, or group the terms with the same variables, and of course the constant is to be transposed on the other side. Then extract the numerical coefficient of your variable on the second degree, okay, in its group, and of course apply completing the square method. And take note to multiply the factors when you write it on the other side to make it balance. factor the perfect square trinomial and simplify the constant. And of course, your standard form should always be equated to 1. Okay, so divide both sides with the constant. Get the lowest term of each factor and then the denominator and equate it to 1. So there you have it, our steps in converting general form to standard form. We are now ready for our last competency, and that is we are able to graph a hyperbola. Okay, so take a look on this first example. X squared over 25 minus y squared over 9 is equals to 1. As you observe from this example, okay, this is said to be centered at origin. And then what else? Our major axis is said to be along our x-axis, or it is said to be horizontal transverse axis. So therefore, our major axis, or a squared is 25, extract it, we have positive or negative 5 units, meaning from the center to your vertex. Okay, let's plot that one. So again, from our rectangular coordinate system, plot our center, which is at origin. And then we know that it is said to be horizontal transverse axis, 5 units to the right. Okay, and then of course, do not forget to label 5 units to the left. Okay, there you have our first step, and that is of course plotting the center and our vertices. Let's proceed. Okay, after the major axis, identify our minor axis, which is 9, and then extract it. Okay, positive and negative 3, this means this is the distance from the center to your ends or minor axis or your conjugate axis. So again, our EMA is said to be along your y-axis. So that means from the center, what? 3 units upward. Okay, there you have it. 3 units downward. There you have it. Let's continue. After identifying your vertices and co-vertices, let's proceed solving our C, meaning C squared equals A squared plus B squared, which is 25 plus 9 equals 34. Then extract it. We have positive or negative 5.83, meaning from the center to your foci or focus. Okay, now let's plot it. From the center, we have 5.83 units to the right. So there you have it, together with the label. Then 5.83 units to the left. Then there you have it. Okay, so we are through plotting our center, our vertices, our foci, and our co-vertices. Let's proceed further, finding our LR, which is what? 2 times 9 over 5 from our formula. And then of course, we have 3.6. And to make it symmetric, we divide it by 2. So we have positive or negative 1.8. So meaning distance from your focus to your ELR. Okay. So we are now ready to graph or to plot our coordinates for ELR, which is 1.8 units. Okay. So starting from our focus, from our f sub 1, 5.83. Okay, from here, we are going to count 1.8 units. That is upward. Okay, there you have. Do not forget to label. Then 1.8 units downward. There you have it also. Then from our second focus, okay, we have 1.8 units downward. There you have. Then of course 1.8 units starting from a focus. There you have. Okay, so after we have plot our coordinates, we are now ready to connect. Okay, we are now ready to connect our and form a parabola, 2 parabolas. So there you have it. Then another parabola here. There you have it. Okay, and we are not yet through. The next thing to consider this time is, of course, again, our eccentricity. Our eccentricity has a formula of C over A, which is 5.83 divided by 5 is equals to 1.166. Okay. Then afterwards, we are now ready to identify our equation of the asymptotes. And what is our formula for finding the equation of asymptotes? X over a plus or minus y over b equals 0. Then, it's just a matter of substitution from the given formula of our asymptotes. So, we have x over 5 plus or minus y over 3 equals 0. All we need to do here is simply apply the positive first. And of course, we have denominators. So what do we do with the denominators? We simply cross multiply it. So this 3 to x, this 5, cross multiply to y. So our first equation is 3x plus 5y equals 0, applying our positive. Then of course, applying our negative, we have 3x minus 5y equals 0. So we are now ready to sketch our asymptotes. Again, from our discussion a while ago, to sketch an asymptote, we draw a dotted rectangle from the 4 points from our vertices. So draw a dotted line out of that. And then from our EMA, there you have it, and it formed a rectangle. And out of it, we are now ready to draw our asymptotes that pass through the diagonal of this rectangle. There you have our 3x plus 5y. Another diagonal passes through the center, that is 3x minus 5y equals 0. So this is now our complete details for our hyperbola, given our vertices, our co-vertices, our foci, our ELRs, and of course our asymptotes. Okay, another example. How about this time if the given is centered at HK? So with this example, identify at once our center, which is negative 3 and 2. So that's right. There you have it. And of course, take a look on our denominator, 16 and 9. And of course, 16 is said to be positive. So therefore, this would make now our major axis, which is what? 4 units. But this time, okay, take a look on our major axis. It is said to be what? Vertical transverse axis. So meaning along or parallel to our y-axis. So let's draw our graph of hyperbola. Okay, make now a Cartesian plane. Let's plot first our center, which is 3 units to the left and 2 units upward. There you have. Then of course, do not forget to label. Okay, from this center, we are going to plot 4 units upward because this is said to be an example of vertical transverse axis. So 4 units upward. So 1, 2, 3, 4. There you have our first vertex, and of course its label and coordinates. Of course, from the center, 4 units downward. There you have, and of course its label, which is negative 3 and negative 2. After plotting our center and our vertices, let's proceed. Okay, identify this time our minor axis. Our minor axis is b squared equals 9. Then extract it, positive or negative 3. This means from the center to your EMA. Because this is an example of vertical transverse, therefore our conjugate axis is what? Parallel to x-axis. So from the center, what? We are going to count 3 units to the right. So 1, 2, 3. There you have our coordinate also. And then, of course, our 3 units to the left. 1, 2, 3. There you have. And of course, our coordinates negative 6, 2. Let's proceed further. This time, our C. So we have 16 plus 9. Okay, it's 25. Extract it, it's positive or negative 5. This means distance from the center to your focus. And of course, again, our transverse axis, it is where the location of our center, our vertices, and our foci. So therefore, this focus would be what? Parallel to your y-axis. Okay, let's proceed to our graphing area. So from the center, we have 5 units upward. 1, 2, 3, 4, 5. So therefore, our f sub 1 and its label or coordinate. 5 units downward. 1, 2, 3, 4, 5. There you have, and its label also. Okay. So after plotting our vertices, our EMA, our foci, we are now ready also again for our LR with the formula. So 2 times 9 over 4. Okay, and then of course, the value now is 4.5. And to make it symmetric, divided by 2, so we have positive or negative 2.25. So meaning this is the distance from your focus to your ELR. So starting from our f sub 1, so 2.21. Where is our f sub 1? There you have. So 2.25 units to the left, 2.25. There you have our first ALR. Okay, and then of course it's label or coordinate. Then proceed 2.25 to the right. Okay, it's label. There you have it. Then let's proceed with the f sub 2. There you have 2.25 to the right. Okay, there you have, and it's label. And then of course lastly, our last ALR 2.25 to the left. There you have it, and of course it's label. Now that we have already our ELR, we are now ready to connect to form two parabolas. Okay, let's start here, upward, and then of course connect here, downward. So there you have our partial graph of our hyperbola. Let's proceed further, solving for our eccentricity, which is 5 over 4. And take note, when we say eccentricity of hyperbola, it is said to be greater than 1. If we compare with the eccentricity of parabola, it's equals to 1. But this time for ellipse, it is less than 1. And for hyperbola, it's greater than 1. Okay, for the equation of the asymptotes, this time centered at HK, here is our formula for asymptotes. So, it's just a matter of extracting. Okay, we have removed the square sign and of course we extracted the denominators. Okay, so there you have y minus 2 over 4, x plus 3 over 3. Okay, and it's just plus or minus, then equated to 0. Again, as we apply, cross multiply our denominators, this 4 to be transposed here, or cross multiply, this 3 cross multiply here also. Okay, so our first equation of the asymptote is simply 4x plus 3y plus 6 equals 0. On the other hand, if it is negative, 4x minus 3y plus 18 equals 0. So again, it's just a matter of cross multiplying the denominators. This 3 cross multiply here, 4 cross multiply here, then simplify, applying your plus or minus sign. Okay, let's graph the asymptotes. First, we are going to draw a dotted line, okay, from our 4 points, from our vertices. Okay, so there you have. And then afterwards, from our co-vertices or our EMA, there you have it. And then of course, we are now ready to draw our asymptotes, okay, connecting or passing through the center from the diagonal of this rectangle. So there you have our 4x plus 3y plus 6 equals 0. On the other hand, again, passing through the diagonal into the center of the rectangle, there you have our 4x minus 3y plus 18 equals 0. So this is now our complete details of our graph for this hyperbola. Okay? Now, let's sum up or generalize for what we have discussed today. First, of course, we have known the definition of hyperbola, that when we say hyperbola, it is a set of all points whose distances from the two foci differ by a certain constant. Okay, next, we have known also our standard form of our equation of hyperbola. Okay, for our standard form, it is always equated to 1. And take note, our major axis or transverse axis is always be positive. Okay, on the other hand, we have also our general form. It is always equated to 0. And therefore, there are two types of hyperbola. So either horizontal or vertical. Okay. And then of course, lastly, we have discussed how to graph a hyperbola, considering the relationship of our major axis or transverse axis, your A, and then your C, and then of course, your B now is referring to your relationship on the conjugate axis. There you have it. So again guys, I'm so happy and hoping that you have learned something today. So thank you guys for listening. And always remember, handang isip, handa bukas. Tara na, ML na tayo guys. Okay? So, again guys, have a nice day and I'll see you in our next lesson. And don't forget to subscribe in our page. Thank you guys.